Okay, this video is going to cover an overview of systems of equations. Specifically, we're just going to go through how to solve different systems of equations, primarily using a calculator as a tool. And there's a couple of shortcuts in this video that were not in Unit 9. So especially when we're talking about larger systems of equations, the shortcuts here are going to come in handy. Okay, so just kind of the basics. Let's say we have we're going to be working with matrices a lot in this video. Let's say I take the sum of two matrices. Well, the resulting matrix is going to be a 2 by 2 matrix. And we just take the location of each point, of each element, and that's where it ends up being in the resulting matrix. Okay, it's a little bit different with multiplication. So if we multiply these two together, we've seen this before, but we do the first row times the first column. And so this is 1 times 5 plus 2 times 7. Then we do the first row second column. So that's 1 times 6 plus 2 times 8. Second row first column, so 3 times 5 plus 4 times 7. And then second row second column is 3 times 6 plus 4 times 8. Okay. And so the resulting matrix from this multiplication is going to be 15, 22, 43, and then 50. Okay, we use matrices to solve systems of equations. And so if I have a system of equation, let's say it's a 2 by 2, 4x plus 9y equals 18, and let's say we have 8x plus 3y equals 6. Well, what we can do here is we can take this and convert it to an equivalent matrix form. It becomes a 2 by 2 matrix, and then we multiply it by the matrix x, y, and we set it equal to 18 over 6. And this is really how we're going to focus. This is our focus for matrices and their applications to what we've been covering in class. So matrices are a tool used to solve a system of equations. And what we did in our lessons is we basically took this and we converted this into an equation where we get ax equals b, where ax and b are all equal to matrices. And the way we solve this is we took the inverse of a on both sides. And what the inverse of a will do is it cancels out with the matrix over here on the left. And so the value of x is equal to inverse a of b. Okay, and what we're going to do in this video is practice kind of this process right here. And I'm going to show you a couple of useful tricks on the calculator that will make solving systems of equations pretty easy, I think, as long as you know how to do it in the calculator. So let's start with problem set number 1. We're going to kind of work our way up. So we're going to start with 2 by 2, a 2 by 2 system of equation. So for number 1, we can convert this 2 by 2 system of equations to its equivalent matrix form, where we have 3, 4, 1, 3. So we're going to take this 2 by 2 system of equations and we're going to multiply it by x and y. And then we're going to set it equal to the numbers on the other side of the equation, 9 and 3. So what we end up with is a. So a. Here's our x, and this is our b. So we have ax equals b, which means that we're going to take the inverse of a and multiply it to both sides of this equation, like this. A and the inverse A cancel out on the left-hand side, and we're left with the following. Okay, so what we're going to do is go to our calculator. So in our calculator, we're going to use the matrix function, and I'm going to plug in this 2 by 2 matrix here. So let's change this to a 2 by 2. And the matrix we used was 3, 4, 1, and 3. Oops. 3, 4, 1, and 3. And then the matrix on the other side was a 2 by 1. So we're going to change both the dimensions and the elements. So this is B. This was 9 and 3. Okay. So the trick is, to make this a little bit easier, our answer is going to be inverse A times B. And so what we can do here is go to matrix, type in A. So this is the matrix A, but we want the inverse. So all we're going to do is hit x to the negative 1, like that. And this is actually the inverse matrix of A. And then we're going to hit second matrix, oops. Second and then matrix again, after we hit multiply, like this. And that's our answer. So 3, 0. So we say the resulting matrix from this multiplication is 3, 0, which means that the answer, x, y, is equal to 3, 0. Okay, let's do this one real quick. So now, once we have this, most of the work is going to be in the calculator, but I do just want to set this up to show you kind of what this is going to look like. So here's A times x equals B. And so the solution here is going to be the inverse of A times B. So in our calculator, let's go to, we're going to change the elements in matrix A. So the dimensions are the same, but the elements are going to switch to 1, -2, 10, and then -4. We're going to go back to the matrix page, and then we're going to edit the 2 by 1 matrix, so it's equivalent to our new matrix B, which is 12, 8, or 12, 8. So now the solution for this system of equations is going to be matrix A, inverse button, times matrix B. And that's our answer. -2, -7. So without using substitution or elimination, we have the answer to this system of equation question. So the x value in this case is actually a matrix, but the way we're going to write the answer is we say x, y is equal to -2, -7. So that's this solution, number 2. Okay, let's move on to problem set 2. Okay, problem set 2. Here we have two 3 by 3 systems of equations. Remember, what we could do here, like we did at the beginning of Unit 9, is we can use elimination or substitution to try and solve this. But the calculator is really going to be a good shortcut. So using that knowledge of matrices and the use of the calculator to help us out here is going to be probably the easiest way to approach these types of questions. So if you have a calculator, definitely that makes these matrix questions or these system of equation questions a lot easier. So what we're going to do here is we're going to take this and we're going to convert it to its equivalent matrix form. Now we have 3 variables, x, y, and z. So it's a 3 by 3 system of equation. And we're going to multiply it by 3 by 1 matrix X, Y, Z. And this is going to be equal to the numbers on the right-hand side of the equation, which is 25, 17, and negative 26. Okay, so the value of this, we're going to call A. The value of this will be X again. The dimensions don't matter. We're just going to denote them as the same letter as we did before, which means that similar to our process in the previous problem set, we're going to multiply each side by inverse A. Okay, and so the X value is going to be equivalent to the inverse of A times B. And so what we're going to do is let's go to our calculators, input A, and then multiply the inverse of A by B. So the main difference between this, what we're doing now, and what we did before is we're using a shortcut on the calculator to find the inverse. So if we have A, we want to change the dimensions here. So this is now we're dealing with a 3 by 3. Okay, so I'm going to enter this in real quick. So 5, negative 4, 5. Once we have it in the calculator, it's not too bad, but the problem is what takes a long time is just entering in the calculator, especially if you have a larger matrix. But either way, it's going to be a lot quicker than if we were to do it by hand. Okay, so that's matrix A. So I'm going to quit and go to matrix page again, and let's go and edit matrix B. So now it's a 3 by 1, and the numbers are 25, negative 17, and then negative 26. Okay, hopefully I didn't mess anything up. So the answer is going to be, the X value is matrix A inverse times matrix B. Okay, this looks like a weird answer. Sometimes the calculators do this. This top number, negative 3.7e to the negative 13th, that's saying negative 3.7 times 10 to the negative 13th. For some reason, calculators don't give, every once in a while you'll see this rather than the number 0. This is actually 0. It's just giving you a very, very small number instead of 0 for some reason. So we're going to use 0 here as our answer. So the solution to this system of equations is as a matrix 0, negative 5, and 1. And so X, Y, Z is equal to 0, negative 5, and then 1. Okay? And let's wrap up problem set 2 by going through question 2. So 2, 5, negative 2, 2, negative 5, negative 4, negative 4, negative 3, positive 6 times X, Y, Z is equal to negative 20, 10, 22. Okay. So the solution here, like it was in the last question, X, which is going to be a 3 by 1 matrix, is the inverse of A times B. Okay, and so let's go to our calculator, and I'm going to change matrix A so it has the correct elements for this specific problem. Okay, so we want to go to, this is will work, 3. Okay, so 2, 5, negative 2, 2, negative 5, negative 4, negative 4, negative 3, 6. Okay, let's go to the matrix page. So we can go to and edit matrix B. And so we have negative 20, 10, 22. And so the solution here is going to be matrix A inverse times matrix B. And hopefully this works. So 5, negative 4, 5. And that's the solution of this 3 by 3 system of equations. Okay. The usefulness of this shortcut is what happens if we have a larger system of equations than a 3 by 3. And that's what we're going to get into for this last question. So here's the solution for this one. 5, negative 4, and 5. And then we're going to go through one more question to wrap up this video for today. Okay, problem set 3. Let's say we have a 4-variable system of equation. Imagine if we were to try to do this by hand using elimination or substitution. It would be kind of a mess. It would take a while. So the way we want to approach this in order to reduce the amount of algebraic work that we're going to do or use is to make this into a matrix. And then we're going to use the matrix calculation on the calculator to determine the solution of the system of equations. So all we're going to do is let's convert this to a matrix. Remember, if there's no number in the front of a variable, like this one, w, the number 1 is implied to be next to w, because 1 times w is w. So we have 1, 2, 1, 2, negative 1, 1, negative 1, 1, 2, negative 1, 2, negative 1, 2, 2, 1, 1, negative 1, 2. Okay. And then, so this is a 4 by 4. And then the 4 by 1 matrix we're going to multiply it by is W, X, Y, and Z. And this is equal to 6, 3, 14, 8. Okay. If we were to try to do this by hand, this would be an absolute mess, and it would take pages and pages of work. So what we're going to do is use a calculator. Same rules apply as before. We're going to convert this into a simple equation, and then to solve for x, the 4 by 1 matrix, our solution, we're going to multiply both sides by the inverse of a. And that will isolate the x term. So x is equal to inverse of a. All right, it's a little bit lower. Inverse of a times b. Okay, let's figure out what it is. So in our calculators, let's go to the matrix page again, and we're going to change matrix A from a 3 by 3 to a 4 by 4. And we're going to enter these values in here. So that's our first row. Negative 1, 1, 2, negative 1. Okay. 2, negative 1, 2, 2, 1, 1, negative 1, and 2. So this is our 4 by 4 matrix A. And now what we're going to do is let's go into the matrix page again, and let's enter in our 4 by 1 matrix, matrix B. So matrix B, we're going to change both the dimensions and the elements in our calculator. So we end up with 6, 3, 14, 8. Okay, even though we're dealing with a 4 by 4 matrix, like I said before, the rules are the same. And so we're going to do matrix A inverse times matrix B. Oh, so this one's nice. It's 1, 2, 3, 4. It's kind of weird. So the solution for this is the 4 by 4 matrix. 1, 2, 3, 4. And so the way we write our solution is we say this is W, X, Y, and Z is equal to 1, 2, 3, 4. And that is the answer for this one. So the calculator is a tool that reduces the amount of algebraic work that we're going to need to use to solve a question like this. If we were to try this question by hand, it would take much longer. And the calculator is really there just to compute those inverse matrices and make the matrix multiplication inverse A times B a lot easier. Okay, and that's it for this video today.